This is Walter Leite. This video is about planning your survey. There are 7 stages of survey research, starting with survey planning and culminating in preparation of the final report. Each stage is essential, building the foundation for both quality and credibility of your findings. So for survey planning, you are preparing the groundwork, including selecting your population, defining the specifications of what a typical population member is, finding a sampling frame, and identify what the questions that and goals that you want to accomplish with your survey. For questionnaire design, you create clear questions that will be understood the same way by all respondents and that will provide reliable data. For pre-testing, you implement activities to understand whether you accomplish the goal of creating clear questions that are understood the same way for all respondents. Survey implementation entails administering the survey with multiple reminders and in a way that maximizes response rate. Also thinking about incentives in this area is critical, and how the potential respondent will see the value of the survey. Data analysis and data coding, preparing the data set includes identifying problems such as missing values, miscoded information. Data analysis, maybe just for, descriptive statistics or more complex inferential statistics, and reporting is communicating the results to text, graphs, and tables in a way that makes the understanding of your findings clear. So for preliminary planning, you first specify the goals of the survey. What are you hoping to learn? And the goals will drive the entire process. You have to make decisions about the population and sample, explicitly who do you want to generalize to, what sampling frame is available, and how does it accurately reflect the population, and also the calculation of sample size. Then you decide the survey method or a combination of survey methods that will be best to maximize the response rate for that specific population that you are surveying. And you also think about the pre-testing. We have you to consider internet, mail, telephone, mixed modes, group administration, interviews. For determining the platform that you implement the survey, such as Qualtrics, and timeline and budget, which goes hand to hand with the survey method and the population. Some methods, such as mail administration, phone surveys, are more costly than internet surveys, so you have to balance that with your resources, and then you create a report template to understand which sections you plan to present data on. Now, to define your survey goals, you have to understand the different purposes a survey can serve. So description would answer questions like what proportion of science teachers use computers for instruction. For hypothesis testing, question like, are athletes training at home less likely to report stress than those training elsewhere? Or it could be a regression question, though the teacher practice in the classroom predict student performance. Could be a needs assessment with a question such as what kind of professional development most interests math teachers or they're in need of. Evaluation, such as does a new science program motivate students to pursue science careers, STEM careers, and longitudinal assessment, such as do attitudes towards science improve over time for students in a science magnet. When you go into the sampling step, you have to define the target population. So, and consider you studying students, athletes, hospital, married couples, populations. You may be targeting multiple populations in a survey, maybe target a single one. The geographic boundaries of this population. So, for example, if you study elementary school teachers, are you studying them in Florida or elementary school teachers in Alachua County? The characteristics of eligible populations, such as bilingual Mexican American students who are between 12 and 17 years old, whose parents do not speak English, or elementary school teachers that are in their first year of teaching in Alachua County. Okay. Then you obtain a sampling frame, which is the actual list that you sample from, and the accuracy of the sampling frame is essential. Select a sampling method that is compatible. Common sampling methods are simple random sampling, stratified sampling, cluster sampling, multi-stage sampling. Then estimate the sample size needed for the survey, which will consider the size of the population and the expected non-response rate. And then you select the sample. Okay. So for defining the population, these are some key questions. What groups do I want to generalize to? How have other researchers defined the population? So look at the literature for studies that were around the same topics and how they define the population. Which geographic area, which may depend on your sources, and availability of a sampling frame also. So for the target population, is it possible to get a list of members of that population? So this is a diagram that represents the relationship between target population, which is everyone you wish to generalize to, the sampled population, those that are actually reachable given your sampling frame. The sampling frame is the list of people that you have. So the sampling frame may contain your sampling population, or should contain your sample population, but may contain not reachable, which are individuals that for which the contact information in the sampling frame is incorrect. And then may also include ineligible, so members that are in the sampling frame but not members of the target population, right? So for example, if you obtain a sampling frame if you want to study like assistant professors in education, and you obtain a sampling frame from the American Educational Association, it will contain individuals that have left academia, and they are not part of the target population, or may contain individuals that are not assistant professors, or may contain individuals that change institutions, so they are assistant professors in one institution, but now they're assistant professors in another institution, so their old email no longer works, they would be not reachable. A good sampling frame will cover the target population as well as possible, and have as few not reachables as possible, and as few ineligibles. The problem is if you have information in the sampling frame about who is ineligible. So for example, my sampling frame for assistant professors, if I have their current employment title, then I can remove ineligibles. But if I don't have that information, I will waste resources in the survey by sending the survey to a sample that includes ineligibles, and I will have to add the eligibility question as the first question in the survey, such as, do you currently work as an assistant professor? Okay, so ineligibles, they make it difficult to survey because they make your sample inaccurate and they waste your resources. So these are some questions to evaluate the quality of your sampling frame. What percentage of the population does the sampling frame cover? It has to be as high as possible. Does the sampling frame overrepresent or underrepresent any group of individuals from the population? You may want to use different sampling rates if you know that some groups are overrepresented or underrepresented. Does the sampling frame contain individuals that are not part of the population of interest? Those will be ineligibles. Does the sampling frame contain correct contact information, which is not reachables? You may discard the sampling frame depending on the answer to these questions, or you may combine more than one sampling frame to obtain good coverage of the population and few ineligibles. So these are some problems. If not all target individuals are included and the excluded group is small but not systematically different, this may be not manageable. Otherwise, you have to look for a better frame. Overrepresentation, underrepresentation, the solutions to use weights. If you have information about the underrepresentation, though, the correct contact information you may supplement with a different sampling frame. Duplicated lists you may be able to remove unless, for example, there are different emails for the same people, but you don't know that they are duplicates. That will create a problem if you have too many of those, because you may classify individual as non-respondent, but he responded through a different email. And ineligible methods, so if you can't identify them in advance, you may have to oversample to account for them. So these are some examples of sampling frames, and they are often in the form of membership lists, foreign directories, school rosters, administrative records, such as state association lists of a survey of educators, list of patients, voter registration lists. Each one has some weakness and strengths. Now, once you identify your sampling frame, you can match it to a sampling method, and some different sampling methods require different levels of information in the sampling frame. So our reference method that we compare all the other methods of sampling is simple random sampling. Okay, so different research questions, populations, resources call for different sample approaches. There is a trade-off between simplicity, cost, statistical efficiency, and ease of implementation. You always have to try to match the method of sampling to your population sampling frame and study goals. So simple random sampling, in terms of precision, which is the size of your confidence intervals, which are the margin of errors of your estimates of the survey, we consider that standard. Consider cost of data collection standard. For requirements for your sampling frame, simple random sampling requires a sampling frame that has individual contact information. Okay. Study sampling is a method that you will divide individuals according to groups, a sample separate for each group. So, for example, if I'm sampling elementary school teachers, I could stratify by their job assignment, so homeroom teachers versus special education teachers versus gifted education teachers, and sampling separate for each group. Stratified sampling, because you were using if you use a variable that's related to the objectives of the survey to stratify, right? So for example, if my survey is about teacher stress and burnout, and maybe I stratify by years of experience, like stratify 0 to 5 years of experience, 5 to 10, more than 10 years of experience as a teacher. That variable is related to burnout and stress. My estimates for teacher burnout will be more precise. They will have smaller margins of error. The cost of data collection is higher because you do need a sample for each of those groups. So you can take as one way to think of stratified sampling is like I'm separating the sample into the strata, such as strata by years of experience, and obtaining a simple random sample for each strata. And so to do that, you need both individual and strata information. So it's not enough to have contact information for teachers. You need to have information about their years of experience if you're going to stratify by years of experience. The cluster multi-stage sample provides less precise estimates because you, instead of selecting teachers directly in a survey of teachers, you would select clusters, such as select the entire school. And so if you, for example, sample schools and then and then select all teachers within the schools you sampled, the teachers within a school will be more similar than teachers across the schools, and that will increase your standard errors, leading to less precise estimates. However, the cost of data collection is lower because instead of having to go to all schools or potentially all schools to get some teachers, you only have to survey certain. You can obtain school contact information and then contact the schools that were sampled, and then just for those schools request contact information for. So the calculation of sample size for a survey is based on the idea of your target margin of error, right? So we do this by thinking of the margin of error of a proportion. So think about elections. Candidate may have 40% intentional vote plus or minus 5%. 5% is the margin of error. So for the confidence interval for proportion, we have the proportion plus or minus a z-score. So for a 95% confidence interval, it would be a z-score of 1.96 times the variance of the proportion, times the standard error of the proportion, which is the square root of variance. And that is P, which is the proportion of yes times Q, proportion of no's, divided by the sample size. So, for example, if you have 250 students out of a population of 8,702 students, the proportion watched reality V is 0.3. Therefore, the standard error would be 0.3 times the square root of 0.3 times 0.7 divided by 250. So you need to think about that standard error to define the sample size. For proportions, the standard error is just the square root of PQ divided by N. And so happens that the largest standard error, so it's the least precision, will be obtained when the proportion of yeses for a question, a yes or no question, is 0.5, so 50%. So because every survey will have multiple questions, and each question will have different proportions, we take 50% yes as the most conservative proportion, and we calculate sample sizes based on that. So you see, sample size is not really based for each question, it's based on this archetypical question, where it's a yes or no question, for which 50% of the population say yes. Okay, so the margin of error for that hypothetical yes or no question is calculated based on the formula for the confidence interval. So say someone may want a 95% confidence interval, and they may want a 2% margin of error. So, and based on a 50% proportion of yeses, so your estimate would be 50% plus or minus 2%. Therefore, the margin of error of 2% equals 1.96 times the standard error, which is square root of p times q divided by n. Therefore, the sample size for that margin of error is 2,401 participants. Okay, so note that it's quite simple, but this formula assumes that your population is extremely large, so essentially infinite, which if you were, for example, surveying teachers in the state of Florida, you would consider that a very large population. Now, because the formula is so straightforward, there are just a small set of sample sizes that would result from this. So here, these are some of them. If you want a margin of error of 5%, which is here at the top, your sample size is 384. So for infinite population, it doesn't really matter the size of the population as long as it's very large. You need 384 participants for confidence interval of 5%. 4% you need 600. 2% you need 2,401. Okay, and that's for the archetypical question where 50% respond yes. I mean, if you change to 70% respond yes, then sample size will reduce. If you change to 90% respond yes, the sample size is smaller. But we typically don't use those lower percentages of yes because it will vary in the population. Now, what if you have a smaller population? Let's say if you were surveying your population were teachers, elementary school teachers in Alachua County. It's not a very big population. It's probably not even 1,000 or ninth grade students in Alachua County. And this population is 2,680. You want a sample size of 384 for a 5% confidence interval. That is pretty large chunk of the population, right? So 384 divided by 2,680 is 0.14, so you are sampling 14% of that population. Therefore, you can reduce your sample by implementing a finite population correction, or FPC. So the finite population correction is 1 minus the sampling rate. So sampling rate is n over big N. So your sampling rate in this case is 14%. So your 0.14. Therefore, your finite population correction is 0.86, right? So it's a number that you then multiply by your sample to reduce your sample size. So the formula on top is without the finite population correction, then you adjust with the finite population correction. So for example, the example for Alachua County 9th grade students, the finite population correction is 0.86. Our original sample size for a 5% margin of error is 384. Therefore, 0.86 times 384, our sample size is 330. You can also adjust by the expected response rate. And you can apply both finite population correction and response rate adjustments if your population is small. Okay, so this is essentially inflating your number of participants so that once you account for the response rate, you get the number of participants you need for that specific margin of error. So let's say the target sample for an infinite population, a very large population, is 384, expect a response rate of 60%, therefore 384 divided by 0.6 is 640. This is the number you need to survey. Now, if you apply the finite population correction like I did in the previous slide, you will need 330 divided by 0.6, and that will be 550.